I felt like we're in. So, we'll just do a good start here. We'll just unmute that here. And we've got some people. And we go, hey, somebody popped in already. That's really fucking sad. So, sorry about the delay. I had a fucking issue getting things at this side. But that's just all cleared up now. And we should be ready to go. And we should be live. And it looks like I am, so I'll just make sure I can hear myself. Cleared up now, and that sounds like I can hear myself there, so that's just all good. I'll just get my live chat pop-out box and fuck that off. There we go. And that's us. Right. Right. I'm too big, so I'm looking awful big. So, there we go. Couldn't do that wee bit. Sit next to you instead of towering over the top of you. How you doing?
Good, you?
Good. Yeah, I'm not too bad. Sorry I wasn't managing to get in while we was there. I, like I said, I had guests in, so I had to wait for them to go and all the rest of it. So that's just fine. So, how you keeping?
Yeah. Pretty good.
Did you pick the link up from the chat, from the
description?
The description, yeah. Cool, that's good. I wasn't sure if it was working, so that was fine. I noticed you was there before I'd even started it. Eager.
Well, first, I was like, well, what is this link? So I clicked it, and then it immediately put me in. I was like, wait a minute, because I was on the desktop and it doesn't have a webcam or anything. So I was like, okay, I'll do it on my phone. I had to install the app and the whole thing. But it was pretty easy. Worked a charm.
Yeah. It's quite a good app. Like I think it's just as good as Google Hangouts, if not better. Yeah. It's got all the facilities to it. You can share videos with it a lot easier. You can share your screen with it. You can mute people, or you can make them louder or quieter. You can do all that things. I mean, I think you can do that with the Google Plus, but you need to install the Google Hangout toolbox or something like that. So, and you've got to start it live. If you go with that, you've got to start live, and then you get used to it. Whereas I don't use that. I just used it for the Hangout. Whereas this way, I've got more control, far better, far more flexible. So,
yeah. But what about kicking people? Because I've heard that in Google Hangouts, sometimes that wasn't possible.
Yeah, you can kick people on this too. That's no problem.
Okay.
Yep, it's handy. I could test it with you if you want. Do you want to get kicked to see if you could come back?
No.
I think everybody can see it. Everybody can see it. Look, just kick out, see? Just there, and it's goodbye. Or I can mute you. Go and speak.
Hello.
Can't hear you. I've muted you. I can't unmute you. I can't unmute you. You've got to unmute yourself.
There we go.
Yeah, there you go. Right, okay. So it's like that. So anybody it's disrupting, we just mute. Yeah, it's working. Yeah, so that's handy.
Good.
And it just needed that for a bit of control on the Hangout. Sometimes you get somebody in, maybe they're in a car, and they're okay in the Hangout, but somebody else is speaking, and all you can hear is the background of the car noise going all the time. So now at least you'll be able to switch that person off until he comes back to speak, and it will, or just turn them down, which makes it easier for everybody else. So handy. Just try to get things so it's a bit smoother, a bit easier for people to communicate with. And it's free. This is the main thing. It's free. Another good thing about it is it's encrypted. Once you use this, you can have conversations back and forward to each other. Also, video conversations, and it's all encrypted. So Google can't see any of it.
Well, then I think I understand why the other guy had such a terrible audio, because encryption needs the processor to do that. And if your processor is not quick enough, it's really going to be shit, the sound and the connection.
Right, okay. Yeah, well spotted. That's exactly what that'll be. Yeah.
So I think that's why.
Yep. Oh well. Well, you can't fix that. Like, you'll have to buy a few more hamsters to get the CPU to run faster.
Or a few extra potatoes and plug in some wires.
Yeah. Well, there's supposed to be hydrogen in potatoes, isn't there? Because they're made out of water. They're made out of water, so they must have hydrogen and oxygen in them. I've never seen anybody getting hydrogen from a potato, though. Have you?
No, I haven't.
No. Everything that contains water must have hydrogen in it. But there's lots of things you can say, well, it can't have hydrogen in it if it's there, if it's supposed to be in water, because it's not possible. And then when you figure all these ones out, you can go, all right, so maybe it's not got hydrogen in it. Have you got any proof that it is? I've got plenty proof that it isn't. Plenty. Loads of proof that it isn't. And I've just got one person, Henry Cavendish, that told me it is. And everybody else listened to him, and that's been it ever since. This was in a time when they weren't sure what these things were. When they discovered these gases, they were just at the start of starting to understand what some of these elements were. And they've decided, oh, well, that's it. It must be in water, due to the experiments he's done. But you can't conduct, you can't get electrolysis with pure water. It just doesn't happen. That's because that's it. That's what it is. It's an element. It doesn't conduct electricity. If you put anything into it, then it'll conduct electricity. But not the water. Now the electricity current, the electric current, is passing through the water because you've put something in the water, you know. Whereas when it's not there, it doesn't happen. You won't get an electric current to pass through water. Now, you've got to then think about this in a more complicated way, because this is the way they want you to think. They've got a problem where they've got two substances. One is called potassium hydroxide and one is called sodium hydroxide. Now you'll know by the name of it that the hydroxide means that it's got hydrogen and oxygen in it, right? So we're quite happy with that. We know that potassium hydroxide and sodium hydroxide. However, if we take sodium and potassium, mix them together as an alloy, if we put them into water, they catch fire. It's fire, there's no metal left, just gas, and it evaporates, disappears, combusts. And that is what happens with potassium and sodium. As soon as you put it near water, if you put it into the air, this is what happens as well. They tell you that it's oxidizing, when it might not be oxidizing, it might be getting affected by the water due to the moisture in the air. You see, well, not too sure about that. But one of the things is for sure, when you put these substances into water, they catch fire. Now, how can it be a potassium hydroxide when if it goes anywhere near water, which is hydrogen and oxygen, it catches fire? How can it be any part of that if it goes near it, it catches fire? It just does not make sense. So we're mislabeling what it actually is. We think it's maybe hydrogen or oxygen that's in there, but it may be something else. And here's Pete. How are you doing, Pete? I can't see you.
Can you hear?
Yes, we can hear you. Yep. Oh, there you go. Yeah, hold on, we'll get you in. There we go. Now they're far better. Look, I've got a nice setup for you all ready to go.
Oh yeah, great. Yeah. So are you live?
Yes, we are live.
We're live, right? So if anyone's got any questions, fire away. We know that water's water.
Yes.
You know, I was talking to, but Sheeps and Neeps was talking. You've just interrupted him. Oh, absolutely. Yeah, you got to make an entrance, don't you? Yeah, you know. We're going to upload a video tonight.
Yeah, that's cool.
Blow your mind. Absolutely blow your mind.
That's cool. Yeah. If you see this, if you go to the right hand side panel, you've got 3 dots at the bottom of this, and it says share a YouTube video. So if you want to share videos, you just click it on there, you put in what the address is, and it shares it with everybody. It's really it's a good little app, this one. It's quite handy, if needed be. So have you seen?
Sure, yeah.
You probably have seen this experiment, but have you seen the experiment where they throw potassium and sodium, the alloy mixed together, into water and it bursts into flames?
Yeah.
Yeah.
We've seen those. We've seen the ones where they do them individually.
Yes.
Do them individually. Yeah, they do sodium, then they do potassium.
They do all the alkaline earth
They do lithium.
Yes.
Yeah.
I think it's the wrong terminology they've been given as a metal. I don't believe a metal should be something that can break down the way it does. I don't think it should even be an element in the description. I think it's more of a compound or a mixture, because as a bit of metal, as whatever metals are, we can't destroy them with fire. You can take fire to them and there they go, they just melt and they're still there. However, with these things, you don't even need to take fire to them. You throw them in water and they disappear. I mean, that surely can't be classed as any kind of metal. And even if you do want to add alkaline at the start of it, there's nothing about it that resembles metal apart from the look of it.
From what we've looked at, there's a lot of chemistry is just messed up in our view when we look at what we've looked at. I mean, as soon as you start, I think the turning point when you start realizing things are messed up, and that is when you start to realize that water is just water and it's not hydrogen and oxygen, because then that makes you go and search for, well, where is the hydrogen? Where is the oxygen? It's obviously not in the water. I mean, we watched a video yesterday with magnesium, and you think to yourself, because we've
share it. Why don't you share it?
Oh, we can share it with you guys now.
Yeah, okay.
This is great video.
We're going to include this in our upload
later
on. So I wouldn't know how to share a YouTube video. Here
Yep.
I haven't got the address. How do you
get a browser?
Find your address.
Wait there.
Just get another browser.
Wait there. Hold on.
Just get YouTube up.
Yeah, hold on.
On the history.
It'll be on the history. Yeah, wait there. I'll just share the screen. I think that might, because we watched it on the history.
You could do it like that, the same kind of thing.
Yeah. Which one would it be?
That's on the right hand side, bottom right hand side. You've got a share screen there.
Yeah. No, it's way before. This one here.
Yeah.
Now you'll love this one.
No, it was the one before because of the. Oh, it doesn't matter.
No, oh, sorry. Yeah, it was. You are right. Yeah. No, you are right. Yeah. Sorry, wait. Sorry to keep you guys waiting.
You've no rush. Absolutely no rush.
Yeah. Was it this one?
No, not that one.
It was because I didn't see the thumbnail. It wasn't that one. It wasn't me there. Which one was it?
Yeah. Well,
we've gone past it.
It's okay. Take your time. Take your time. There's no rush. Like I said, it's not like you're going in for a chemotherapy appointment or anything like that. When I went in for my chemotherapy appointment, I had to react straight away.
We found it. Here you go. You'll love this one. We're going to mute it. We're not going to.
Good idea.
Now, how would
you want the?
Yeah, let's go back on there. Let's share the screen.
Share a video. Oh, you want the
share screen? URL. How do you find this? Share? Oh, sorry, wait there.
URL.
There.
Copy.
We're going to do it this way. You'll love it. You guys will love it. There you can view, share a YouTube video there. Oh,
yeah.
Paste. There you go. Right.
Share.
It should have the link in there. We're all watching this, yeah.
It'll come up. Yeah, that's it.
Yeah. Yep. Now, it's just a video.
Reactions of metals with steam.
Reactions of metals with steam. Now, we know steam is just steam. It's just water. It's not hydrogen and oxygen. Okay. Now, you guys will love this. I'll tell you, because it is so good.
Yeah, it is.
It's wonderful.
When you've got your eyes opened, it's amazing what you can see.
Absolutely. When you've got your eyes open, you can see so much. It's unbelievable. Whereas when you've got them closed because you've got a lot of rubbish in your head, so much confusion, you just can't see what's obvious,
What's happening?
Can I get rid of this?
Just click it off.
Oh, no, I can't.
You can pause it. That's it.
Oh, no, I've got...
It just says
yeah, sorry. No, wait there. Let's go now. This guy. Let's see what. Now this guy. Wait there. Where is this? Not there. No, I'm just waiting for the bit.
Yeah, this is it.
This is it. Now, I'm just going to pause this. What they're going to do after this diagram is that they're going to copy this demonstration, but they won't use iron. They'll use magnesium. Okay.
Well, they use iron to begin with. Then they use magnesium.
Right. Okay. So what they're going to do is they're going to they're going to put a piece of magnesium, stroke iron, whatever, into a boiling tube, which is there. They're going to pass steam over it, and they're going to heat with a Bunsen burner the iron or the steam. Okay. And then the gas will come out into the flask, and then you'll get a gas come out, won't you?
Yeah, but there's a slight. They do it a slight.
They do a slight variation. So in here, let's play this from here. Okay, sorry, wait there. Right. Yeah. So from here to the lab, they go to the lab.
Put the sound on.
Well, let's go. Let's put the sound on.
Steam over some iron. Have a look at what's happening to the iron when I heat it up. The hot steam passes over the iron, and just as we heat it up, the iron should start to react with it. We've got lots of steam escaping, but just now we're going to see something else happening as well. As you can see, the iron is changing to a darker color. I'm going to do exactly the same experiment, but this time I've put magnesium into this test tube.
Right, is everyone clear what's going on?
Oh, I think so. He's seemingly burning a bit of iron. Did he say?
He was the first demonstration. It was iron. But he's passing steam
over the iron,
or into the boiling tube.
Yeah,
and he's heating the boiling tube, which has got the iron in it.
Right.
And now in this one, he's going to do exactly the same, apart from he's going to use magnesium. So, okay, we'll play it, and then we'll
have a look at what happens when I heat up the magnesium. The steam is passing in and passing over the magnesium. Can definitely see water vapor inside the test tube. Oh, look at it, starting to glow. Cool. And you can see it's turning white. I wonder what gas is escaping there with the water. I'm going to test it. I think there might be hydrogen coming out with some water. It might not give us a pop, but we never know. Look, it's burning. A clear indication that the flammable gas is being given off.
Right, yeah, so everyone saw that? Right,
what are people's understanding of what's happening?
He's put a gas over the top of it. I could hear myself coming back loud as fuck.
What do you guys think?
I don't think. Give me your explanation.
Right. Okay. You'll love it. You see, these guys think that hydrogen and oxygen are contained in water in the steam. Okay. Now the guy's heating the magnesium up in the
boiling tube.
Okay. The steam's going into the boiling tube. It gets so hot. Okay, that the magnesium catches a light. Okay, and it starts to glow. Okay, I think we missed that one. And what's happening is that he uses a lit splint, and takes it to the end, okay, where he lights the gas that's coming out with the steam, because it's a superheated steam that's coming out, essentially. It's very dry. Now, what we can see from this is simply that because of the colour of the flame that's produced, which is red, if we wait there.
Ready, purple.
Wait there. Get it, wait there.
Needs to go back.
I need to go back, wait there. I'll just try.
I'm going to test it. I think there might be hydrogen coming out with some water. It might not give us a pop, but we never know. Look, it's burning.
There. Can people see that it's a red colour? The flame. Yeah.
Now, I can highlight it there, look, see?
When we first watched this, we thought, damn, this is a demonstration that shows hydrogen in
in
water.
water, because it's obviously, some people would interpret this demonstration that the hydrogen gas that's burning here
It's coming from
is
water.
coming from the water.
So we thought, no.
We thought, no.
It's coming from the magnesium.
Oh, no.
Yeah,
we're wrong. But it's coming from the magnesium.
But it's actually coming
Yeah.
from the magnesium.
I would say it probably isn't coming from magnesium until it catches fire and then starts to release the gas.
Absolutely, yeah.
Yeah. But magnesium doesn't burn with a red flame.
Magnesium just burns with a white light.
Yeah.
And when you go and have a look at how magnesium is made, most of it's made in China. About like 90% of the world's kind of like supplies made in China, and they use calcium as part of that production.
Right.
And calcium burns with a red flame,
Right.
which would account for the red flame we see here.
So magnesium is an alloy of calcium.
Yeah, I mean, you've really got to, you've got to understand essentially that a lot of the elements aren't elements in the regard that they're containing other substances. For example, calcium. We saw calcium in our last video. We saw calcium being kind of like reacting with water, being broken down by water, and it's giving off a hydrogen gas. But the hydrogen gas is contained within the calcium. Yeah, it's not in the water, it's in the calcium. So calcium metal contains hydrogen. Now, we're not saying that calcium isn't an element. We are saying that calcium is an element, but when you purchase calcium metal or a calcium compound or a calcium whatever, it's likely it's got hydrogen in it.
Okay.
And it's the same with potassium. It's the same with magnesium. It's the same with, lots and lots of other things. Lithium. It's the same with loads. It's all. They're all. We're led to believe that with chemistry, the elements are set and separate. So when we get sulfur, we've only got sulfur in it, but that's wrong. It's not the right way of interpreting the periodic table. The way of interpreting it is that the substances we're using contain other elements.
Yeah, because you have to look at how they actually manufacture.
Absolutely, yeah, of course.
Those elements.
Yeah.
To know what's actually in them.
Now that makes perfect sense, doesn't it?
If you made a cake, for example, once you take it out of the oven, there you go.
I'm going to put some coconut, I'm going to put some raisins in it, and I'm going to put this in it and that.
You can cut it up, and then you can see what's inside it without knowing what ingredients you put in it.
Yeah.
Chemistry is exactly the same.
Yeah, absolutely, yeah. Chemistry is exactly the same, but at the end of the day, in our opinion, yeah. But at the end of the day, it's a contrived understanding that oxygen and hydrogen make up water. It really, really is. I mean, it just, it's just.
Yeah. But this video is a great demonstration because we've done a lot of electrolysis with a number of different electrolytes, and we've burnt the cathode gas, the hydrogen, and we've always had the color of the flame has always been reminiscent of the stuff that's being electrolyzed.
Absolutely, yeah. So if we're using, say, calcium carbonate, for example, and we tap off the hydrogen from there, it's going to burn with a red flame. If we're using, say, like sodium, it will burn. If we're using sodium chloride salt, it will burn with a yellow flame. So we're looking and seeing that the gas hydrogen, if I can use the word, I use it very loosely, but that's coming from the substance. It's not coming from the water.
Yeah.
I mean. Like I said before, and that is, as soon as you start taking hydrogen and oxygen out of the equation from water, you can start understanding what's going on in these chemical reactions in a totally different way. But it's a much better way because it makes you understand what's exactly going on and how these chemicals are being produced.
Yeah.
Yeah, absolutely. We'd make great chemistry teachers.
Yeah. Well, we're going to look at it from the perspective of let's investigate what's happening and let's see what's happening, rather than going with the preconceived ideas of we've already decided what it is and this is what it is. And it's like, hold on, please, sir, I've got a few questions that aren't going along with what your plan is. Be quiet and just accept it. And it's like, no, we're not going to accept this just now. We want to get tangible proof of these things, because it's getting more ridiculous as we go on. We've got to remember that these people thought of these ideas over 100 years ago, when they were just starting to discover these things. And they may have made mistakes. But we should look into this further. We find that they probably have made mistakes, but science isn't willing to accept this. They're quite stuck on the fact that it's made of hydrogen and oxygen. And like I said, I've got about 101 reasons it's not. And this is you bringing along another one now. And
there's an awful lot. I mean, it's just like the globe Earth. There's an awful lot of information that supports the idea that the Earth is this spinning ball, but it's exactly the same with water. There's an awful lot of information that supports the idea that water is made of hydrogen and oxygen. Yes. We've got the demonstration here. We've got electrolysis. We've got pH. We've got what else? There's
for water vapor.
Water vapor. We've got loads and loads of other stuff. A lot of science can explain water in terms of hydrogen and oxygen, given its construct that it's built for itself. But it's only the idea that hydrogen and oxygen are in water. That's all it is.
Because in this video, he was firstly he was burning iron, but he didn't actually get hydrogen gas out of the tube.
Mm-hmm.
And yet you would have thought he would do, because he's still passing steam over that.
Absolutely, yeah, of course.
You should still get the same result.
Absolutely, yeah.
All that should be different is you've got you've got an iron type of hydrogen.
Absolutely, yeah.
But it shows that there's no hydrogen in iron.
Absolutely. After doing this after I think the past three weeks maybe, since I've been made aware of it becoming more popular, or people are thinking about it more, talking about it more. Water not being H2O. Even I think to myself, I can't understand anyone who thinks water is H2O. I just can't. I can't.
Yeah.
I can understand why, but I just can't understand how they can justify to themselves that water's hydrogen and oxygen.
It's the same with the globe, right?
Yes,
it's what they've been told.
Yeah, exactly the same. But I think the worst thing is that you can go down the route of many information pathways. Whether it's to do with chemistry, physics, history,
health,
geography, health, the lot, and you can biology, the lot, and you can start thinking, well, this doesn't make sense, that doesn't make sense. You get into a point where you've, like Vic says, he says to a lot of people, we've all been told a lie, and I wouldn't say we've all been told a lie, but we've certainly been, because a lot of people don't realize that they're lying. But I think a lot of the time it's people just it's all been misconstrued and misdirected to cause an awful lot of chaos and confusion in the minds of the masses.
Mm-hmm. Absolutely,
yeah. Really, But what did you think? What did you think of D.A. Brownlee's video? Because I saw you left it in a little email you sent.
When was it? Oh yeah, I know.
When he did his battery and
yes, nonsense. Every question that I was given to him, he would give me back some completely abstract answer, and it seemed okay to him. It seemed plausible to him, but to me, no. It's no. It's not anyone else. Yeah. Complete stories.
Yeah, what did you think? What did you think of his little
I couldn't really call it an experiment because I mean,
they're not the experiment.
I mean, what I can't understand is why on earth is this guy? Okay, he's obviously out to debunk, but
Team Wolfie,
yeah. But why on earth is he putting 2 leads in an empty glass and not connecting them up to a battery source or a power source? How ridiculous is that?
It's try to do some kind of, oh look, I've done a blind test. Like, are you serious?
Yeah. What is the point of doing? I mean, none. Yeah. He must think that people are really, really stupid.
Well, he would have been better off just doing his first one.
Yeah,
absolutely. Because I left him a comment and I said, "How does that? What are you trying to prove?" Because I couldn't. It wasn't clear as to what he is exactly trying to prove, achieve. You know. And when he replied, I still wasn't sure on what he was trying to do. You know,
it's because he doesn't know himself.
It's because it's very clear. You know. I mean, we did a similar.
He thinks copper oxide's blue.
Absolutely, we did the same thing again, didn't we, with the 10p's? And we actually got some corrosion with the 10p's quite far apart in a tub filled with deionized water. Now, what we've done,
we didn't get the bubbles.
We didn't get any bubbles, but we did get corrosion on one 10p that was connected to the anode, the positive end terminal of the battery. So what we've done is that we've varied the demonstration a little to see what exactly if we can pinpoint why it's corroding, because we know that it's not conducting electricity.
But we've taken the conduction right out of the equation.
So we've taken the conduction right out of the equation. But I mean, we think to ourselves, well, you know, there's an awful lot going on, isn't it? The one thing I find amazing, and that is when you see the corrosion on the coins. How is it possible that a nickel-plated steel, ours is steel, nickel-plated steel. How is it possible that a nickel-plated steel coin, the steel that's inside the coin can come to the surface? How is that possible? Isn't that weird?
Yeah.
Isn't that amazing? Mm-hmm. So, because I asked that D.A. Brownie, I said, well, do you not think that's amazing? How the substance that's inside the coin can come to the surface.
It's coming out.
It's coming out. It's being drawn out of the coin. It's amazing, isn't it? And yet, when you think about it, we don't get this kind of knowledge or this kind of like education, as it were, you know, because I don't even think that D.A. Brownie knows.
He doesn't. You
know, I don't think he knows. But I mean, it's just bloody interesting stuff, you know. So, you know, we're toying with the ideas that, you know, we know the water doesn't conduct the electricity, so it's just quite interesting how we know that when it becomes impure, because the coins are corroding, so the water's going to get impure, so then you'll start getting some conductivity. But it could be the fact that what's going on is that the electricity, because it's wired up to the power source anyway, it's kind of like pushing on the ions that are in the coin. I mean, I don't know. I'm just kind of like throwing things out.
Anyone's guess.
Anyone's guess. I mean, I don't know, but it's just worth. It's great to get to a point where we're actually discussing this rather than talking about, you know, well, there is hydrogen and oxygen in the water, and they're the ions that, you know, all this kind of rubbish.
It's better talking about this than curvature of the Earth.
But absolutely, I'd get bored talking about curvature of the Earth, you know. But you know. Well, what were your views anyway, Sheeps? Des, on his why he got when he umped the power up, you know, he was getting quite a lot of corrosion forming.
Yeah, he was conducting his test as he liked. What he was wanting to do was try and prove that he was getting hydrogen and oxygen out of it, and to me, that's not what he was proving at all. So whatever other tests he was trying to do or whatever he was trying to prove was failing to me, because it's not accomplishing what he thought it was accomplishing.
like I've said, he wasn't clear on what he. I couldn't understand what he was trying to achieve.
Exactly. Yeah. My point was there's supposed to be hydrogen and oxygen in this water. What are you trying to do? And he decides to start using fucking coins and things without even connecting it to a battery. Like, what's that going to prove? Absolutely nothing. That's like just sitting it beside the toilet and hoping for it to do something.
I think he was hooked on the colloidal silver video that we put up. That and he wanted to maybe just debunk that. But I mean, we do things, and we just think to ourselves that, what makes common sense here? Let's apply some common sense as to what's going on here.
Yeah, so, we can see what's happening.
That's all we do.
Yeah, we know by just a simple search that we can find lots of information that has got to do with colloidal silver, and we can find lots of this new fancy flask looking like things. They're like this tubes like this, and they'll be about this size. You fill them with the water and you put the little switch on and it hydrogenates the water. It gives you hydrogen water, which is really beneficial. How do you get this? No, you just get it from the water. That's it. You just put the water in and it pulls the hydrogen out of the water and makes it so now you've got hydrogenated water. And it's so lovely and tasty. I mean, I've never heard so much nonsense in all my life because, one, there's no hydrogen in the water. So what the hell is that shit that you're trying to tell people that they're getting? Now, the colloidal silver is on the same kind of thing. We've got evidence to say, that's not happening. And it's rocking a lot of boats. It's putting a lot of people out of business. It's putting a lot of businesses are like, we don't want that information getting out because we believe there's hydrogen in that water, and our business thrives on the idea that people believe there's hydrogen in the water. So if you tell them it isn't, we don't know what we'll do. And I'm afraid that's the stage we're at, because we've got proof that there's no hydrogen in your water, and all they've got is fancy gadgets that helps promote the idea that there might be hydrogen and oxygen in the water, because these things are telling you, it's separating all this for you, it's giving you ozone and it's giving you hydrogen, and these nonsense claims that they've got that are supposed to be coming from the water. We pretty much know it's a load of rubbish.
Yeah.
We can test these things in several ways. We can test it. We can test it, one, with the mass and the volume of these gases. When they're a liquid, they cannot be compressed any more than they actually are. That's the full compression of what they are. Now, the problem is, when it comes to hydrogen, you've got like 11 litres or 14 litres, I think it is. Let me just have a quick look. It's up the top here. You've got 14 litres. For 1 kilogram, you've got 14 litres of liquid. Right? Now, that's a liquid as in hydrogen. And that's a liquid as in oxygen, which has got 0.87 litres for 1 kilogram. Now, the problem lies in the fact that we know the weight of water, and water is also a liquid. Now, if you take that liquid that is supposed to be hydrogen, regardless of how much you want to use, you cannot compress it any more than it is. Its volume will take up 14 litres worth of area. You see, you can't compress that volume down to get it into the volume of what water is supposed to be. The weight doesn't match up, the volume doesn't match up, and just dealing from there, we can tell that you can't make water from it. So after that, then we've got the proof that we can't get it out of it. So if we can't get it out of the water, and we can demonstrate that we can't get it in because of the simple weights and measures don't add up, then what's the big confusion about thinking there actually is hydrogen and oxygen in it, apart from someone telling us it is, when we've got loads of proof to tell you that it is not made from hydrogen and oxygen.
Absolutely. Yeah, can't knock you on that at all. I think it's what to say. What can you say?
Yeah, what can you say?
What can you say? I mean, I think everyone here is probably pro water as
I would take it.
Yeah, we're okay here. You're in good company here.
Pro Walters. You know, it's strange how we've gotten to a point where you know, 3 years ago, you know, oh wow, flat Earth, wow, that's amazing. Oh, you're joking. People think the Earth's flat. You know, well, it's the biggest conspiracy out. You know, blah blah blah. And then you know, a few years later, you know, we're starting to see more information emerge. You know, because I'm sure it will. That even water, you know, water is just not hydrogen and oxygen. You know. And the beauty about it is that, you know, you don't have to, you know, it's just a way of understanding. That's all it is. Because some people will click straight away. Oh, right. Yeah, of course.
No,
you know,
two gases.
I mean, we did with flat Earth. But as soon as someone watches a video about water, oh, wow. Yeah, of course. It's so simple, isn't it? Yeah.
Yeah.
You know, and they do a bit of research on the information that supports, the idea that water is H2O, and then they'll start realizing that it's just all rubbish, you know, blah blah blah, and it's, you know, you're getting nearer and nearer to issues that people should be talking about and that people should be more aware of in their lives.
Yeah.
And I think that's more of a realistic way to live people's lives. You know, realistic way to live your life. I'm not in dreamland. You know what I mean?
Oh yeah.
Yeah, exactly. I know.
You know, I mean, I don't want to live dreaming and thinking that, you know, this is A is I don't know, A is left and B is right when it's the other way around. You know, because I just think that's just a waste of time, isn't it?
Yeah. Or listening to people's stories.
Or listening to people's stories. You know, talking about
shit.
Yeah, talking about crap. You know. Yeah. I mean, I'm unsure whether people are religious here.
No.
I'm sure there's people that have varying different types in the chat. I'm not sure, but everybody would have to give their opinion on where they are. Like, but you know, most people are open.
Yeah.
I know that much. Most people are open-minded. I think more people will be probably along the spiritual side rather than Christianity side. But that's something that ask people as well.
There's a much better way to go, spiritual side.
Yeah, it's being in tune with your humanness, yourself really, rather than, you know, being told what to believe in. You know,
believing something in the outside.
Yeah, it's the belief system. It's just getting away from the belief system, isn't it? I mean, the whole society that it's built upon, that we live in, is a belief system. You know, believe in the globe, believe the water's H2O,
believe in Santa Claus,
believe in Santa Claus, believe this, believe that, and yet it's a rubbish way to live your life.
Yeah,
you know, in our opinion, anyway. You know, but you know, that was a great demonstration with the magnesium, wasn't it?
Oh
yeah,
absolutely wonderful. Because we did. Did you watch the video where I put on the wig and the little nose?
Yeah, I did. Yeah.
Now I've got to admit, when I made that, I was thinking to myself, yeah, you know, you won't get oxygen from electrolyzing sodium chloride. Okay,
but we were wrong.
But we were in certain respects we were wrong, because the more we electrolyzed the sodium chloride, we got to a point where the gas at the anode that was coming off was changing, and it had a bit of hydrogen in it, it had a bit of oxygen in it, and it's the bottle smelt of chlorine.
Right.
Had a slight taint of chlorine, and we're thinking to ourselves, where's this gas coming from? Because, like, you know, as soon as you realise water is water, you start thinking, well, there's no oxygen and hydrogen in the water, so where's this oxygen coming from? We know the hydrogen's coming from the sodium, part of the sodium chloride. So where's the oxygen coming from? And then it transpires that the oxygen comes from the graphite electrode that's breaking down an awful lot. It broke down. We were changing it every day, because it was breaking down, because the chlorine had been expended from the solution,
it was free. The water, and this is in my opinion what's going on, the water was free to decompose the electrode and obviously release the oxygen that was contained in the electrode, because graphite, we realise graphite contains oxygen.
Yeah, because it's when they make it, they put it through a kiln.
They put it through a kiln
10 hours.
10 hours at 1,000 degrees centigrade. How much, if you've watched our videos on calogen, the whole idea about, oxygenating or calogenating substances, you get a feel that this is where the oxygen's coming from. And, so it's quite easy to understand that the oxygen's not coming from the water. It's coming from the substances that it's reacting with. And this is why they don't use platinum. It's not recommended to use platinum electrodes with sodium chloride, is it?
Why?
It's because you won't get the oxygen coming off.
Possibly, yeah.
Yeah, you won't get the oxygen coming off, so you'll start to realise that you'll start to realise that absolutely, you'll start to realise that there's no oxygen there.
Yeah,
that's why. It's a great little scam at the end of the day.
Yeah, basically, yeah. So a lot of it's all contrived.
It's all contrived. I mean, we found a bit of information about your friend Cavendish as well.
Yeah,
last night.
Yeah.
That guy's crazy.
Well, to be honest with you, one thing I'm beginning to realise, and that is, you see, when you look at the sciences, physics, chemistry, biology, even as well. When you look at all of the sciences, it's a wealthy man's. Rich man's club. It's their education. It's not ours.
Nope.
It's there. And you begin to realise that these wealthy people are just as messed up, or even more so messed up than what kind of like we are. And what makes it even worse is that a lot of them are just as stupid, or even worse. They're stupider than what we are. Yeah. A lot of people, you tend to think that Henry Cavendish, for example, he was this great man, and Ernest Rutherford, he was a great man, and Isaac Newton, he was a great man. But a lot of the time, these people in reality could have been stupid, absolutely stupid, because their ideas now can be picked we can pick holes in them. So they couldn't have been that clever.
Exactly.
Absolutely, yeah. It's just the way it's all transpired. But it makes us realise that we're just as clever as what these guys are. There's no difference. But it's just our current situation. Economically wise. Within society, because it's only money that separates us. Essentially, we live in a society where money essentially is the determining factor as to who holds what position. Essentially, in society, money holds an awful lot of clout, doesn't it?
Oh yeah.
So it's just so you can have this really stupid person who's making laws. Yeah. Who can't think straight. Who can't. Who's some people might think he's a bit mad. Do lally tit and everything. But he's in a position where he's voting on laws and all this lot. I mean, it's crazy, isn't it? What a crazy system.
It is, Yeah, well, it is laws. These are things that have been, just like any criminal law that's been passed through the courts. This is something that you're not allowed to argue against. It's like, no, gravity's there, and it's a law. It's a theory. It's just a thought. Avogadro's number. It's just... Now... One of the things that's really concerning is the atomic mass unit, and this has to be known to everybody. This really needs to be known. We have a number that Avogadro has decided that this is going to be the quantifying number to correspond with everything on this periodic table. The number is going to be 6.022 times 10 to the power of 23. This is the number. You take the numbers that they've also attributed on this periodic table, and they've decided that oxygen is going to be like 15.9999. Now, I thought it was 16. Yeah, we'll round it off, because that's the amount of neutrons or protons or something that's in it. This is the weight of it. I was like, okay, but you're deciding this on a neutron or a proton or an electron, sorry, you're not doing it with any neutrons at all, because there's no neutrons in hydrogen. Therefore, it can't be a neutron that you're basing it on. It has to be the protons in the atom. But what is more important is, once you calculate this number, scientifically accurate is what they call it, when you calculate this number scientifically accurately and you come up with a sum, it has got a fraction of a sum. Now round it off. What? Round it off to the nearest whole number. And that gives you how many atoms you have in that substance. Now, correct me if I'm wrong, but you can't get fractions of atoms in any substance. It's either going to be an atom or it's not going to be an atom. It can't be a fraction. So why are you using this number and then saying it's bloody accurate and then rounding it off when you get your answer? It's just complete lunacy that you would take that as a law, as like this is fact. I mean, it's clearly not fact, because it's dealing with fractions or something that are supposed to be wholes. That's it.
Yeah, but it's all done mathematically.
Yes, it's just nonsense.
And with mathematics, it's quite common for things to be rounded up.
Yes.
So, but that's where it all exists. Is mathematics.
Yeah, it's just mathematics only proves the maths. If somebody says the maths proves whatever, then it's only proving the maths is only proving the maths. The maths can't prove anything other than the maths.
That's right.
Yeah, basically. Yeah.
So 2 and 2 equals 4. You can work out a calculation or whatever, some kind of equation to prove that 2 and 2 equals 4. But all you're doing is you're proving the maths. You're not proving reality, because you're not dealing with reality. You know, you've come back from reality and you've forgotten all about it, essentially, and you're working in abstract ways, and you know you're using those abstractions to be able to communicate to other people, and you're building up your whole kind of view on reality through an abstraction, which is it's wrong to do that. You know, it's a lot better to have reality to work on. But in my understanding, you know, I've come to the conclusion that the trouble with human beings is that human beings cannot understand reality. Human beings don't know reality, because
certain things are
out of our hands. You know, we don't know what the moon's made of. We don't know how the sun works. We don't know what the sky's like, blah, blah, blah. We don't know what water is, you know. As soon as you take out the hydrogen and oxygen from water, well, what is it? You know, it's a very, very interesting question. We can see it. It feels wet to the touch, but what is it? You know, we can't. A lot of people think, well, you know, we're not happy to have it just as being water. We want to know what is water. But you know, it's one of those questions that, you know, human beings can't answer, because human beings are just like another kind of animal that's on the earth, you know, and we're subservient to nature.
Yeah.
So,
well, this is the other one that they've got as well, and well, in fact, I'll make this one's easier. I will go through this, and then we'll talk about gases and how they think this expansion of gases is. Let me just flick this on here. You should see my screen.
Yeah.
Yep, okay, if I just start this.
In this video you are going to learn what the 3 states of matter are, some examples of each state of matter, the characteristic properties of the 3 states of matter. The 3 states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, The properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either. But they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons, because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they are far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
And that's that, right? Now, one of the things about that volumes there, where am I doing here? Right. One of the things about that volume, with liquids and gases, you can see how you can compress. And when it comes to a liquid, you can't compress it. It's just impossible to compress. So once it's a liquid, we know that that's its volume. And with gases, same kind of thing, no fixed volume, but it can be compressed and uncompressed. Now here's the dilemma. We know that if we have gases at a certain temperature, we can start to lower the temperature, and the more we lower the temperature, the more we'll get something to then turn into a liquid. We can do this with hydrogen, we can do it with oxygen, nitrogen, helium, we can do it with all these. And as this temperature comes down, their molecules that they're in becomes more condensed, and they will come down to what their size will be as a liquid. And this is the same for anything. And every single substance, every element that we've got, has got a different temperature at what it will turn into a liquid at. Is this right?
Yeah, I would imagine. I don't. Some may be the same, but yeah.
Some maybe, yeah. Yeah, they've all got a different boiling point and a different freezing point, yes. And because of that, then we know that they are changing from their gaseous state to a liquid state. This is how we can determine that. And every one, like I said, has got its own property and what descent it will do this at. Now, if that's the case, how is it possible for every single gas to be of the same molecular density of 22.4 at standard room temperature? How can they all be the same if they're all different at different temperatures? How are they all the same at that temperature? Now that's a fucking flaw. That's not true. And it's another law that is there, but simple deducement tells you that that cannot be.
Yeah, I mean, there's so much. You see, the thing.
Yeah, but carbon dioxide is much denser.
Exactly. Exactly. So it's not going to be the same as 20.
Yeah, they have that.
They're all supposed to be. Yeah, they're all supposed to be 22.4 at STP, and that's like no, that's not possible. I don't understand how that can be, because they all display this at different temperatures. So therefore, they're bound to be different at 0 or whatever temperature they want to pick at random. You know?
And where'd you get that information from?
Because every gas that we know has a different boiling temperature and cooling temperature and liquid temperature, where it will become these different elements or different stages. And Avogadro's law stipulates that at room temperature or at STP, standard temperature, then all gases will have a molecular density of 22.4 atoms. They're all going to be exactly the same. And that's just like, no.
Is that a theoretical law?
Yes, it's a fucking theoretical nonsense. Exactly. It's not a proven fact. It's a theoretical one.
Oh, whose law was this?
It's Avogadro's.
Oh, I've not heard of him. So
you have heard of him. Of course, you've heard of him.
Have I? No.
Avogadro.
Avogadro. No, I've never heard of him.
Avogadro. Right? Wow. Avogadro is the guy that's developed the fucking atomic mass unit. He's the one that's turning everything from G-moles and says instead of using grams and kilograms, he uses this fancy thing where every particle per mole is, you take a multiplication of 6.02 times 10 to the power of 23. And that's how many particles there is in every mole of every single substance ever known to ever be existing. And it's just like, weighing shite.
Yeah.
So
I mean, if you was to look at your chemistry, like, I don't know, 10 years ago or even 20 years ago, this mole idea wouldn't never have been dreamt of. No one would have ever heard about it. But it's like nowadays you're starting to see it more and more. 6 mole of this, 7 mole of that, and if you had 14 moles of this and all this, but it's just in my understanding, it's just a fashion, because you've got to have new things to
development.
Which gives people the impression that there is development within the sciences or within certain things that are being studied, and the moles really are just meaningless.
Yep. There it is.
It's just to give people the idea that chemistry or physics or whatever
it's development, it's moving forward. But it's not. They're still doing the same tests that they were doing 200 years ago.
Yeah, because the substances
haven't changed. Yeah. How can you produce sodium hydroxide, for example, and get it more pure than what you can now?
Yeah, exactly.
You can't. It's ridiculous. Hydrogen, the manufacture of hydrogen. How can you beat steam reformation? You just can't do it. It's one of the best, most productive means of producing hydrogen.
Yeah.
So it's just there's no. I don't see much development in chemistry and physics and all of these sciences. But when you get into the globe society, the globe society has got to show to the people that things are developing, things are progressing.
But they only do it in the words people use.
But they only do it because they change the words.
Yeah.
So instead of grams, it's moles.
Yeah. Well, here's the way that they put it. This is the way they say it. Like, go on in, eventually.
Or to put it another way, the principle that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. Thus, the molar volume of all ideal gases at 0 degrees Celsius and a pressure of 1 atmosphere is 22.4 Ltrs.
That's it.
Well, we're aware of ideal gases.
They're not quite so ideal, are they?
Well, yeah. I mean, it's a hypothetical idea situation. It's very difficult to actually have an ideal gas, even by its name. But an ideal, what do they mean by an ideal gas? Could it be that what they mean by an ideal gas is that it's pure?
No, because they've got a real gas. You'd think the pure one would be the one that's called a pure gas, a real gas, right?
Well, yeah. After doing the videos with the colloidal silver, it makes me realise that, and having a look at what we looked at with the magnesium, it makes you realise that purity is something that's very hard to achieve. I remember talking to some guy on YouTube who said that achieving pure water is very, very difficult to do. So if you even when you look at deionized water that you buy from your B&Q or whatever, even that will have impurities in it, a certain degree of impurity in it. But to get actual water that's clean
and free from any impurity is very, very hard to achieve. And it's the same with elements. It's the same with, when you buy your silver bars to make your colloidal silver, for example. When you buy magnesium, when you buy calcium metal, sulfuric acid, when you buy sulfur, when you buy potassium, all of these substances have got other elements in them.
Sorry.
No, that's fine. It's
because it's all about money.
Well, it's all about money because it costs an awful lot of money to make substances very, very pure indeed. They'll be so expensive it would be unbelievable. I mean, that's probably why when you look at platinum, silver, gold, a lot of the noble metals, because they exist in a very close pure form, they're very expensive. Well, it makes sense, doesn't it?
Oh yeah.
Whereas if you've got a lot of shit in something, you can flog it cheap, can't you? Yeah, it makes sense, doesn't it? Absolutely.
Yeah, but you would have thought if it's a pure metal, then there's less production costs.
No, there could be more production costs if you want to make a pure metal, because you've got more work to do to get it pure into a pure state. I don't know. I'm just surmising. I'm not saying that it's right or it's wrong, but to me, it just seems that if you want to get something that's very pure, you've got to put more work into it to get all the impurities out of it. Well, if you look at aluminium, for example, with bauxite, if you look at iron ore when they make steel, all of these ores have got impurities in.
Yeah, I know. Yeah.
So you've got to have effort and work to extract all of the impurities, so that you're left with just the stuff that you want. Just like the graphite. I mean, they mine graphite, and they basically mix it with oil. No, they mix it the graphite that comes out of the rock. That's brought up from the mine.
Water and oil.
I mix it with water, oil, and essentially the pure graphite rises to the surface and is just skimmed off the top. Now, all of the shit on the bottom, they don't want all that shit. They just want the bit on the top. Yeah. But you've got to do that process in order to get rid of the impurities. And then you've got to do it about 5 times, wasn't it?
Oh, yeah, because it's all about
5
refining.
It's all about refining. You see, the thing is, when you look at the substances that we're using, when you buy them, when you look at all of the elements on the periodic table, a lot of them have to be a lot of them have gotten to be in their very close to be in their purest state. So they've got less shit in them. So your magnesium, for example, will have magnesium in it, but we know that it's got hydrogen in it as well, because we see it from the color from that experiment or that demonstration, the color of the gas.
Yeah.
So magnesium that you buy isn't that pure because it's got hydrogen in. Because you and I, we're kind of like developing a little idea on what we think hydrogen is and where it's coming. Well, not where it's coming from, but what the purpose of hydrogen. It's only an idea, but we know it's not in the water. We know that so it frees us up to be able to think, well, where's the hydrogen coming from?
And when we're trying to challenge people about water is not H2O, if we can actually come up with an idea of where the oxygen comes from, then it gives people something to think about. Now, if we can come up with where the hydrogen comes from,
absolutely, yeah,
then
an alternative,
and we can demonstrate it.
We can demonstrate it because that's all we have to do. We've only got to demonstrate it.
Then I think we've got a sound
argument in order to put forward. There's no hydrogen oxygen in water. Absolutely, yeah. Because absolutely, it's really, really good, isn't it?
Yeah.
Because the thing that we've done in our videos is that we've been able to give people food for thought where they can go out and do some testing, do some electrolysis, or do some other kind of tests to actually kind of like make them understand where we're coming from. Because a lot of people don't seem to understand that. D.A. Brownie with his, what he was doing with the coins, for example. I mean, I don't know what he was doing, what he was trying to prove, what he was trying to demonstrate. But just the fact that he's doing it means that he's having to question the information that he's been given. But these people aren't doing experiments with the curvature of the Earth, or finding the horizon, or this or that. Well, they're actually doing stuff with water, which is, something that everyone can do, which is great stuff.
That's a screen for later, that one.
Yeah. But you'll love our video tonight, I'll tell you. You'll love it.
You've put one together, have you? Explaining some stuff.
We need to do it, but we know what we've nailed it, haven't we?
You've nailed it. You've nailed it.
We've nailed it. Yeah, you'll love it. It's going to scare the shit out of loads of people. I'll tell you. Yeah.
Oh, I see. So is this a plug for the video rather than explaining it? Then is it? Is this your method of madness? Is it?
It's probably because I'm a bit excited about it, because it's like Peter woke me up last night and he said I've sussed it, and I'm thinking, do you know what I mean? This is like 5, 6 o'clock in the morning, and he's going, I've sussed it, and I'm thinking, for fuck's sake, I want to get to sleep.
It's very much when you've got an idea that there's no hydrogen in water, and you see this demonstration, and you think, we're wrong. We're wrong. Fucking hell, we're wrong. How can we debunk this?
Absolutely, yeah.
And then you come up with an idea that says, "Oh right, that'll explain it."
Because all it is, it's just finding explanations.
Basically,
you're arguing with people over word. You're arguing with people over words, essentially, and people will say to you, "Well, but if water's got to be hydrogen and oxygen because of this." And you're saying, well, no, it doesn't have to be because of that, because we've demonstrated this. All the time that you can provide some demonstrable information, that supports your view, then you're free to put forward your view, and it makes it very, very hard for all these people to disprove your claims. It really, really does. And I've got to admit, the claim we're going to make tonight is, you'll love it. You'll love it. Yeah, be great. Who's the surgeon?
Who's the surgeon?
He's a surgeon.
He's splitting the water.
No, he's writing.
Okay. So have you got your show booked for the night? Have you set it booked, or are you just going to throw the upload up? How are you going to do it? How are you going to release it? You should have did a live show. Whoops. You should have did a...
Sorry, say it again.
You should have did a live show. You should have did a reveal,
A live show.
Yeah, we thought about that, but we thought, I don't know whether... Yeah, we prefer just doing the videos, don't we?
Well, we know that Del Beyond the Imaginary Curve, he had a live show, and he got his hacked. And I'm sure we do attract a lot of globies, we do.
Yeah. Oh, right, yeah, sure. Yeah. I mean, they just love it. Yeah, the worst thing is that, you put forward these claims. I mean, I've got to admit, over the past, say, maybe year, really, the past year, I mean, I suppose some of our claims have been, well, the only claim I can think of that's been incorrect was with the fire triangle, because we got to a point where we thought that the fire triangle is wrong, and that it shouldn't be oxygen, heat, and fuel, but it should be air, heat, and fuel. Now, so because of the information that is lacking on the internet, we actually had to generate a flame, ignition flame, within an oxygen-rich environment ourselves, because the information wasn't there. Now, it's ridiculous when you're having to do the stuff yourself, because the information should be there. But doing it ourselves has shown to us essentially that you can get a flame in an oxygen environment, but that doesn't prove that there's oxygen in the air.
Yeah.
All it proves is that you can get a flame in an oxygen-rich environment.
Oh, yeah.
We can't extend that line of thought out into the real life because we haven't demonstrated that there's oxygen in the air.
Yeah, I know. Yeah.
There's a question come in. Look, it says Des, it's just flicked off. Do Peter and Pete know anything about testing COD in water? That's what
CO2.
COD. It's saying. Well, I'd imagine it might be a 2. I don't know. I don't know about that.
I would imagine
it's probably a CO2.
Probably CO2. As far as we're aware, there's a lot of misconception concerning CO2, carbon dioxide. That's if the question relates to CO2, because CO2. The only test for CO2. Okay,
there's a couple of them.
There's a few of them, but the major test for CO2 that's established, tried and tested, that mainstream science tells us, and that is lime water. Lime water will turn calcium hydroxide. Lime water will turn cloudy in the presence of CO2. Okay. Now we've done some. I wouldn't say we've done extensive testing, but we've done some demonstrations. We've played around with lime water, and we came to the conclusion that it's an alkaline substance that will turn lime water cloudy. Okay. Anything alkaline will turn lime water milky. Now you go on Wikipedia and you look up general information about carbon dioxide. Is carbon dioxide an alkaline substance? And then it transpires that it's not. It's an acid gas. So you've got to ask yourself, okay, how can the CO2 turn lime water milky?
When it's acidic.
Now we've actually
COD. They're asking. I think it's COD. I don't know what it is.
What is COD?
Well, what's COD?
What is COD? Cod, like a fish.
Cod.
I don't know. Chemical oxygen demand. Chemical oxygen demand.
Chemical oxygen demand. Not familiar with it.
It's like HOD, hydrogen on demand.
Oh, chemical on demand.
Carbon on demand.
Carbon on demand. Is it?
I haven't heard of it.
I'm not aware of the
concept.
I'm not aware of the concept. Chemical oxygen demand. Is that it? Yeah.
No.
I don't know. I've never
come across
that
one.
Chemical oxygen.
Yeah, you can. You see, the thing is that I'm well aware.
Is that relating to oxygen generators?
Are we talking oxygen generators, oxygen concentrators,
oxygen concentrators,
pressure swing absorption stuff? Is this what we're talking?
I'll see. Get a reply.
Because you see, one of the reasons why I think a lot of people haven't touched this stuff is because a lot of people don't have haven't developed the proper way of tackling all of the naysayers. It's like, because you can get oxygen concentrators that produce oxygen, you can get pressure swing absorption generators which will generate your oxygen and nitrogen, all from air. Now, I know we're moving on from like CO2, now we're moving on to air, but in our understanding, when we created the superheated steam, we were able to bubble the superheated steam through water and collect a gas in a jar. Now, in our understanding, it's likely that gas we collected was distilled air. Because you see, the thing is, when you boil your kettle. Okay, now let's go on the fact that water is water. It's not hydrogen and oxygen. When you boil your kettle, you'll see tiny bubbles appear. Now, in those bubbles are air. There's not hydrogen and oxygen. They're just air. and those bubbles will rise to the surface. And because what we've done with our superheated steam, cooling it down, bubbling it through water, and then collecting the gas, distilled air, what we've made, in our understanding, what we've got from water is air. Now, in our understanding, water and air are closely linked. There's a bond that is inseparable. You know, when it rains, we see the puddles of water on the pavements. Okay, get a bit of sunlight out. Okay, the water disappears. Water disappears. Even the water vapor. You know, we've seen water vapor coming off of the roofs because it's so hot, but the water vapor itself disappears. So, in our understanding, it's quite likely that the water becomes air. So, water is liquid, and air is the gaseous form of water. Okay. So now, given that, we've got to think about, well, what about the constituents of air that science tells us? The oxygen, 21%, the nitrogen, 78%, CO2, the argon, and such and such and such. How do they work? Because our understanding is that air is air, and the gases that float around in the air are very much like your impurities you find in water. Okay, the air is the pure stuff, and all of the other gases, you know, your oxygen, your hydrogen, your carbon dioxide, they are your impurities. So if we relate it to the water, it's easy to understand if we look at it that way.
Because air and water are just mediums.
Air and water are just mediums. What they are, I mean, like I said, you know, what actually is water? I mean, who knows? I mean, I haven't a clue. What's air? I don't know. I haven't a clue. But
yeah, guys. Oh, sorry. I just wanted to pop in quick. I don't know how good the sound is going to be. What you've been talking about, ultra pure water. I dropped a link into the chat and I said to pass it to you. But I've got this company that I found in India. I'm going to put the link for it in the side chat here for you guys to look at. Take a look into this company, and I've been looking. They make purified waters for the medical industries and all that, you know, for pharmaceuticals and stuff. Now, they call this product they use ozone, yeah? And what they do is they get water that they see as pure, you know, or as pure as they can get it. And what they're doing is they're using this product called ozone as a catalyst. They're claiming something similar to the ozone in the atmosphere, yeah? And they're calling it O3. Now, they're saying it's a gas that dissolves in water. But from what I've gathered through this site, from what I can gather, it's liquid oxygen that they are using through as in a process, pumping it into already almost water, oxygenating the water, allowing it to perform electrolysis on the water, which they call a slightly different name, and they're getting this highly oxygenated, super pure water. But then I think, why do they have to pump some form of oxygen gas or liquid or whatever it is they're saying into water? You know, this is like very, very dead. So I just wanted to say this here. I've left the link in the side chat here, and take a look at that company, guys, and look into, and it's really funny when you start to read through some of it, they don't tell you what this ozone is, or until you read sort of halfway through different things, then you will see that it's something they're adding. You know, they talk about it as if it's something that's just the same as the ozone in the sky.
It's all it is. It's just a product. It's just a product. Yeah, they can sell a product. They can sell. You know, that nobody wants. But it gives people jobs. It gives people. It fills it. Well, it's oxygen. Everyone's heard of oxygen, haven't they? Also not oxygenated. Oh, we don't want air, do we? We can't have air because then that's too easy. That's too simple. We want oxygen. We've got to have the oxygen in the water.
O3, that's what they're sort of calling. Actually, more than the site, because they use it for different treatments depending on what the end use of the water is.
Yeah.
You'll gather, I mean, the links in there, take your time when you get a chance, just look, have a look. I'm going to draw back because my quality's really bad and I don't want it.
Your fucking network is crap, man. You're just brocking up constantly.
We'll do that. Yeah, because we know that O3 ozone. Well, from the information we've looked at, ozone O3, okay, is what occurs when you get a lightning strike.
Mm-hmm.
When you get a lightning strike and the lightning essentially burns the air as it's passing through it, and you get an ozone gas generated from that lightning pass through the air. So obviously it's going to change. There's a lot of heat there. It's essentially changing the composition, changing the air, and it's basically very similar to when we talk about calogen and our ideas about oxygenating substances. So instead of heating it, you're getting you're electrifying the air. Yeah. So the air will change and go into this ozone, become this ozone gas, which then rises to the upper atmospheres because it's so light. And I mean that's our understanding. But one of the things that we've thought about, and that is, it's okay for man to create ozone gas. But the thing is that when we think about pollution, when we think about how the air works, that we all breathe, we've got to think about, well, is it possible that all of these pollutants, all of these impurities in the air reach a point where the air becomes pure? So there is no impurity as such. There's no pollution problem. There's no, it's just a thought. It's not my firm understanding, because I don't know, but just worth throwing out.
Well, that makes me think for what you said about the lightning strike. So if the lightning is, like they're saying, creating this ozone, the O3, then why are they having to inject this so-called the ultra pure water to get it to be able, so they can do this analysis on it? So guys, it's just terrible. I'm going to drop it.
Are you listening to it at the same time or something? He's probably trying to listen to it at the same time and see how shite it's coming back, using up twice as much bandwidth than it needs, and then wondering why he's not fucking sounding good.
That's all right. We got his point.
Aye.
Yeah, we got the point. It's a good. I mean, you see, the thing is, as soon as you start, it's like Pandora's box at the end of the day. As soon as you start unraveling certain rubbish in society, you can't stop. You've just got to continue on and on and on, because there's so much rubbish to unravel, and you've got to build up your own understanding in order to explain the rubbish that they've created,
and why they have it.
And why they have it. I mean, O3. Hey ho. I can understand that, when a lightning bolt strikes, it's obviously going to change the composition of the air. It's going to change air. It's going to have an effect on the air. I mean, we're talking how many volts of, electricity. How hot is that as well?
Yeah, but when you think about it, it's no different, because they're aiming it as ultra pure. Was it ultra pure?
How can you? Yeah,
or whatever. They're aiming that product at hospitals, medical,
ultra pure water.
Hygiene,
absolutely.
And it's no different to
distilled water.
A company promoting a machine that can extract the moisture out of the air and produce drinking water. It's just a product.
It's just a product. Yeah, it's just a company wanting to make money.
Yeah.
It's just another way of making money. It's just, I mean, a lot of people, even these globe people, tend to overlook the fact that we live in a money-orientated way of life system, and it's that money that drives a lot of the bullshit that's in society. So when you get people wanting to put a product on the market to do this or to do that, it's only to get money. It's not there specifically to that it works and that it helps people and that it's going to be of benefit. So you just got to be very careful. I think anyway.
Well, colloidal silver.
Colloidal silver is a very good example. I wouldn't take it, but I mean, at the end of the day, it's colloidal corrosion. Does corrosion make you feel better? Does it? If you've got aches and pains, does it do good for you? I mean, I don't know. I haven't a clue. All I know is that when I look at the muck at the bottom of the jar, I certainly wouldn't want to touch it.
No, it doesn't look great. It doesn't look great.
No, it doesn't. And all they do is they stir it up.
Oh, well, yeah, they stir it up. So it's good for you.
Give it a stir. Yeah, that'll be fine for you.
Good for you. Yeah.
How many bottles would you like? 2 bottles.
Yeah.
Oh, that's lovely.
And if you're the brownie, you can make blue.
Absolutely, yeah. If you do brownies, now he's got it right. I got it wrong because he's made genuine 100%.
Oh, is he?
Colloidal cupronickel.
Yeah.
See, because I didn't realise that the 10p's in the UK are made from 1999, was it, or something?
No, 2010.
2011. Sorry.
Whatever.
The 10p's, our 10p's, are made from steel. A nickel-plated steel.
Right.
Yeah, and you think, well, I can't get it. I thought it was cupronickel.
Which is why your liquid went yellow.
Which is why my liquid went yellow, and his has gone blue because he's got cupronickel coins because he's in Australia and he's using coins that have cupronickel.
Yeah. So
it's so easy to understand.
Why did yours go yellow?
Because of the steel that's inside the coin. The steel, the iron ore.
Oh, yeah.
The iron ore, because that's the base of the steel, the iron ore. I mean, it's but like I said, the interesting part about the colloidal corrosion is simply how is it put? It's wonderful, amazing how that corrosion is able to seep out, to be drawn out of the metal.
Yeah.
It's absolutely amazing.
Yeah,
because you tend to look at metal and think, well, yeah, they look pretty solid to me.
No, you tend to think that corrosion occurs on the surface.
Absolutely.
But in fact, it occurs within the.
Yeah, because the electricity. When we look at de Brownie's little demonstrations, what his demonstrations do show, and that is the electricity does either act as a true catalyst, in that it certainly speeds up the reaction, the rate of reaction, or the electricity actually also helps to decompose the coins as well. We've got to have an open mind as to what actually is happening in that very, very simple demonstration, haven't we? But we've got another one lined up. We're doing one at the moment because we just want to test whether it's going to happen, whether the water's got anything to do with it, essentially, aren't we? So because science is all about testing just to eliminate variables, But why his power one was just showed to me that the electricity either acts as a catalyst, speeds up the rate of reaction, decomposition, or it actually has the ability to decompose substances, impure metals, for example.
Yeah.
And the reason why copper, when we look at electrical appliances, electrical circuit boards, and all this lot, a lot of the conductive materials that are used mainly are good conductors, like copper. Sometimes I'm sure they use gold in certain instances, silver, because these substances are pure, or as pure as.
That's what gives.
And the flow of electricity will not decompose them.
Yeah.
Makes sense to it makes sense to me.
Yeah, it does. It's complete sense. I think they have these things. A lot of these elements need to be recategorized as to what they actually are, the definitions of them.
Yeah.
Well, it's like we're
looking at oxides.
Oh, because you mentioned earlier about hydroxide containing hydrogen and oxygen. Now we've come to the conclusion that some of them shouldn't be categorized with the hydroxide label at all.
Yeah, because it depends on the process. Because I don't know whether you're familiar with the chloroalkali process. Sodium chloride, the electrolysis. Sodium chloride with the membrane.
With the membrane, yeah.
Now, mainstream says that you're left with, on the cathode, you're left with a sodium hydroxide solution. But in our understanding, it can't be a sodium hydroxide solution, because if it was a true hydroxide, as mainstream would label it, you would be able to electrolyze it and get hydrogen and oxygen from the electrolysis.
It would be, the substance would be polarized.
But we actually had some calcium metal, and we've actually placed it into a tub. Like what you were talking about earlier, you see the metal reacting with the water.
Mm-hmm.
Now, the calcium doesn't catch fire. It just dissolves, basically, but it releases a lot of hydrogen.
Because there's hydrogen in the calcium.
Absolutely. But mainstream says that when it's dissolved into the water, it's calcium hydroxide.
It forms a white precipitate. Called calcium hydroxide.
Now, our understanding is that, well, if it's a true hydroxide, you should be able to electrolyze it.
Absolutely, because it's polarized. But we're finding at the moment that it's not really polarized at all, because it's like getting blood out of a stone.
Yeah.
Isn't it? Really?
Because normally what they do with these precipitates in solution is that they normally dry out.
They normally dry them out. Evaporate the water off,
and then dry out.
Dry them out, and then process them.
Hundreds of degrees centigrade.
Yeah, and then process them.
Yeah, and process them. And they might actually add something to it.
Yeah, they might actually add something to it, like
which gives you your hydrogen and oxygen.
Absolutely, yeah. They may use this because the word catalyst is very flagrantly abused as far as I'm concerned, and they may process this hydroxide that's been evaporated and dried out with a catalyst that then the substance is able to take the oxygen from.
Yeah,
for example, it's all messed up, and it's all just messed up, isn't it?
Yeah, I think a lot of it with chemistry is that if you can understand how things are made, then I think you've got a better understanding of chemistry.
Yeah,
than looking at the formulas and this, that, and the other.
Yeah, absolutely. Yeah, it's just production. That's production. That's the key to it. Because if you want to bake a cake, then you're going to have to look at how it's made. How is the cake made? You're going to actually have to do that. So to give you a better understanding on, what it tastes like, for example, and how it performs, how well it cuts, how long it lasts for, and all this lot. But it's the same with chemistry. And the substances you're creating, if you can go back and see how they're made, even from like way back to a substance that you're just bringing in and putting a little drop into the mix, because it's all, the whole's greater than the sum of its parts. So you've got to look at it from a very, a whole picture.
And some of the vital information they don't tell you.
Absolutely, yeah. Those little bits of information that are absolutely vital in understanding, they omit. We'll cover one tonight, which will be absolutely wonderful. And people think, oh, right, yeah, I know where it comes from.
Fuck's sake.
You'll
release it sometime tonight. It's great.
No, I'm sure everyone who's listening here will love.
I would like to hear it as well. It would be really interesting. You can release some more information about it.
We're going to kill something, I'll tell you.
Yeah,
probably.
Probably, yeah, absolutely, yeah. But it's just more information. It will certainly fuel more debate, that's for sure, because it's it'll open up a whole new area.
Yeah, that will. Yeah,
open up a whole new area. You know, and you see the thing is, you know, that's what it's all about. It's all about getting people to debate, to discuss. You know, we just put the information out. You know, we put out our views.
But you haven't put it out yet. You haven't put it out yet, though, have you? You're kind of holding on to it, pretending that you put it out.
No, I've got to be. Yeah, I've got to be. What's
diplomatic.
The word?
Diplomatic.
To be honest, to be honest with you, Des, I just like doing. I like doing our uploads because I feel that it's a lot easier to put our point across in our uploads rather than talking, you know, in a live chat like this, you know. I just think it's a lot easier, you know. It means I can run away as well.
Yeah.
If we get something wrong, we can sort it out.
You can still sort of do it live. You can sort of do it live, so somebody can correct you straight away, and you can go, "Oh, I never thought of that." See, that's what I like about it.
It's one of those things where you think, if you have it in you that there's no hydrogen and oxygen in water, and then someone comes along and says, look, I've managed to get the hydrogen out of the water, then you have to ask yourself, where's he getting the hydrogen from?
Absolutely. Yeah, where are they getting it from?
Now, you have to apply that same kind of understanding to other areas,
absolutely, and you'll never look back, and you'll always have that. You'll develop a lovely inquiring mind. I'm telling you, that you'll treasure for all of your life. It will never let you down as well. You know, you can trust it 100%.
Yeah.
Which is great. But there we go. So. There we go. Yeah, wonderful stuff.
Yeah.
So how are you finding that the responses you're getting from other people with your
very positive.
Your take on the hydrogen and oxygen, water?
I would say very positive. Yeah,
positive. Yeah, we've had quite a few people who have just snapped at the idea. Yeah, water's water.
Yeah.
It's because it resonates so easily with people because. Well, this is my opinion, but it resonates easily with people because people can interact with it every day, and you know they know that. Well, if they buy some water, some deionized water from the shop, and they fill up their glass with it, and then they add something to the water, they know that they're adding an impurity to the water. You know, it's easy to understand. If you know what I mean. And it's the impurity that will change slightly the water. No, well, not the water. Sorry, the water always remains water, but it will just change the composition
of that solution.
It will turn it into a solution.
Yeah.
You know, people can. It's tangible. It's something that's really good. Whereas when flat earthers talk about like star trails and all this kind of stuff, you know, that you can't really. You can't.
Well, you're bringing in some way.
You're conjecturing
quite
often.
With water is not H2O. You're actually bringing the flat Earth kind of argument closer to home.
Yeah. Well,
you know, you're actually bringing it where you can get water. You can do things with it.
Yeah.
Well, I would like to say, right, we've got hydrogen and oxygen, and it's 2 parts hydrogen to 1 part oxygen. Okay, this is what they tell us. 2 parts hydrogen to 1 part oxygen. Now, however they try and mix this, I don't know, but this is what they say. You take your 2 parts hydrogen, mix it with a 1 part oxygen, you'll get water. Now, if you have 4 parts hydrogen and 2 parts oxygen, that's almost the same thing, but it's like more. You would say it's like almost heavier water. Now, you get that, then you add a carbon to it also, and now you've got sugar. Now, I don't know how you're supposed to have sugar by just adding a carbon to it from what it is when it's just water. Considering water, we know it's got no taste, there's no smell, and then you're adding carbon to it, and now it's got a taste and a smell. And this sugar is very, very sweet. So it only leads to the conclusion that carbon must be sweet. It must be sweet. But then you go and mix it with something else, and you just change the hydrogen and the oxygen and the carbon by a number or two, and now it's butane. So how can it be butane, and then it be sugar, and then it be water, all from this three things? It just doesn't make sense.
Yeah. I'd like to point out to you one thing, and that is we did just before Christmas. We get into a habit of coming up to Christmas. We want to do something because it's Christmas. So last Christmas we did a kind of like Peter and Pete's top 10 science myths, and one of them we'll actually confirm tonight. Oh yeah, one of them will confirm tonight. But our number one science myth in our list was that carbon isn't an element. Carbon is like a ghost element. Carbon essentially doesn't exist. In other words, you go